Hello students, today we are going to discuss about detection of double sideband with full carrier AM modulated waveform. So this is also comes under first unit amplitude modulation, and the course outcome is distinguish various AM communication systems. The first topic is demodulation. So the demodulation is otherwise called as detection. It's nothing but the process of extracting, modulating our information signal from the modulated signal. Otherwise, we can define it. It is a detection, is the process by which the message is recovered from the modulated signal at the receiver side. The devices used for demodulation or detection is called as demodulator or detector. For amplitude modulation or double sideband with full carrier modulation, the detectors are categorized square law detector or non-linear detector. Second one is linear detector. The low-level modulated signals are using non-linear detectors to recover the original message signal. So first we will discuss about what is square law detector. As I told earlier, detector is used to demodulate the modulated signal and recovering the modulated signal. So this is especially for non-linear devices. So the square law detector is used for detecting low-level modulated signal. Again, the diode is used, operated in non-linear VI characteristics. The non-linear characteristics of the diode, the square law detector is similar to square law modulator, the same operation. So whenever the diode receives the positive half cycle, it is operated in forward biased mode, we will get the output accordingly. When it is reverse biased, the diode is in off mode, then we will not get any output at the diode. The same principle. So in square law modulator, we are using band pass filters. Here we are using a low pass filter to obtain the desired frequency. The operation is limited to a non-linear region of the diode characteristics. So the lower half portion of the modulated waveform is compressed. This produces the envelope distortion. So the average value of diode current is no longer constant and varies with time. The average diode current consists of steady DC component and time varying modulation frequency. So due to this non-linear operation, lower half of its current waveform is compressed. This may cause envelope distortion. Due to this, diode current will not be a constant and varies with the time period. So this is the circuit diagram. Whenever it receives the positive cycle and it is operated in forward biased mode, the corresponding output can be taken across the capacitor. Whenever it is operated in a reverse biased mode, then there will be no output, so the capacitor start discharging, so we will not get any output at this terminal. So mathematically we can express this as EAM is equal to EC into 1 plus EAM, A2 into EAM square according to the square law. So EAM is equal to EC into 1 plus MA sin omega MT into sin omega CT from the square law modulator circuit. So substituting EAM in the square law equation, we will get this equation. So after expanding these equations, we will get all these higher ordered equations. So these higher order equations can be eliminated with help of this low pass filter RC. So the remaining term will be carrier and EC sin omega CT sin omega MT components. So the carrier term is filtered by using low pass filter, and high frequency term are also reduced with the help of the detector. So we can get A2 EC square MA sin omega MT. So the final outcome contains a signal with modulating frequency. Hence we can able to recover the frequency by this circuit. So this is square law detector. Then envelope detector. So from the name itself, envelope, the envelope of the modulated waveform, we are going to obtain the modulating signal. So we are going to retrieve the envelope of modulating signal. From that we can find out the modulating signal. That is why it is called as envelope detector. So detector which output follows the envelope of the modulated signal, which is used to reproduce the modulating or message signal, is called as envelope detector. This is most popular commercial receiver circuit since it is very simple and not expensive. So this is the circuit diagram of envelope detector. The principle of operation: modulated signal is applied to the series of diode and low impedance, which consisting of a resistor and RC. Operation takes place over the linear region of VI characteristics of diode. For positive half cycle of a carrier signal, the diode deconducts, thereby the capacitor charges to the peak voltage with the time constant tau is equal to RC of the carrier signal through the resistor R. As the input falls below the peak value, the diode reaches cutoff. The diode acts as an open switch and hence the capacitor gets discharge path through R. During negative half cycle, the diode is reverse biased and the carrier voltage is disconnected from the RC circuit. So the capacitor discharges continuously until next positive cycle appears. From the peak of one positive cycle to the next capacitor discharges slowly, and this process continues. Thus the voltage across C is same as the envelope of the modulated carrier, but spikes are introduced. So the output voltage across the capacitor is spiky modulating, and it may be a baseband signal. So the envelope is detected at the output of capacitor. Thus from the average value of original signal is recovered by extracting the envelope. The spikes can be reduced by the amount by keeping the time constant RC value as more. So the capacitor start discharging negligible amount, we will reduce the spike amount. Then we have to choose the RC value in a proper way so that we can reduce the distortion. So large or small value of time constant makes problem. So time constant is an important consideration. If the time constant RC is quite low, then the discharge curve during non-conductive period is almost vertical. So fluctuations may occur in the output voltage. This results in diagonal clipping. If the RC value is large, then the discharge curve is almost horizontal. So several peaks will be missed in the distortion in diode detector. So there are two clippings in the distortions. One is a negative peak clipping, another one is diagonal clipping. We will start with diagonal clipping. So as I told earlier, this diagonal clipping happens when we fix RC value as quite low. So we have to fix the RC value in a proper way. When the time constant of a detector is not selected in a proper way, the modulating voltage is faster than the rate of voltage fall across RC combination, which results in distorted output. This type of distortion is called as diagonal clipping. So this is the diagonal clipping. So when we are choosing the RC value is very low, there is a clip or there is a distortion in the diagonal of the signal. So to avoid the diagonal clipping, proper RC value has to be selected. The voltage across RC combination during the non-conducting period of diode is Vc at instant t, which is given by Vc of t is equal to V0 into e power minus t by RC. By using this mathematical expressions, the slope detector, the slope of the envelope is given by MA EC omega sin omega mt. So when we equate this equation with the right hand side, we can express that 1 by RC is greater than or equivalent to MA omega m sin omega mt divided by 1 plus MA cos omega mt. So to find the maximum amount of RC, differentiate the equation above equation with respect to with respect to t and equate it to 0. So we will get this equation, that is cos omega mt is equal to minus MA. On substituting the values of omega mt in this equation, we will get this equation as RC is greater than or equivalent to root of 1 minus ma square divided by ma into omega m. So we can fix the RC value by choosing the modulation index and modulating frequency in a proper way. We can avoid the diagonal clipping. Then the next one is negative clipping. So this is due to the maximum constant values of RC. The second source of distortion is linear diode detector is curvature of the diode characteristics. So as a result, in the efficiency varies. It will reduce by selecting the load resistance as a large value. So RC is large, then the modulation index will be low and signal becomes clipped at the negative peaks. So the negative clipping provides AC and DC load impedance unequal. So to overcome this, we have to go for a proper way of choosing RC